afternoon, everyone. Hello. My name is Kajal, and I'm leading the licensing department for all of the Kowai Limited product. I'm here to introduce Clemens, who is a top integration mind from Microsoft, who's presenting on event-driven architecture. We are extremely delighted to welcome him to this year's edition of Integrate. In this session, he will guide you towards maximizing the use of Azure messaging services in building event-driven architecture. With a big round of applause, please welcome Clemens.
I get music, that's new. Well, welcome to the session at this yet again excellently organized conference by Kowai. Thank you for having us as guests. In the next 45 minutes, I'll be talking about event-driven architectures. And of course, this audience here is unlike every other audience that I'm speaking to because you're all experts. So what can I teach you? Which means that many of the things that I'm going to be talking about are things that you're using in your daily life. And so what I'm going to try to do is not necessarily convince you of this, because you're here, so you're kind of already convinced. But I'm trying to give you a bit of a vocabulary that you can go and work with when you're talking to customers and how to think about event-driven architecture. So I'm not going to go very deep, but I'm mostly kind of talking through concepts and trying to talk about some vocabulary. It's about event-driven architectures. There's a second term that has been coined by James Urquhart, who I've been doing some podcasts with and also helped with a bit with his book called Flow Architectures that he wrote to kind of give a bit of a frame of reference for what we're dealing with these kinds of architectures, which is very interesting. It's not very deep. It's one of those books which gets unjustified low reviews for not being concrete enough. But the point of that book is not to be concrete, but to be an overview, a survey of what's currently there, and a bit of speculation of what might happen. So that's a good book. And so I'm also using that term flow architectures for this as well. And I'm taking flow a bit further than just purely eventing, and also includes flows that are imperative. So I'll start with a few pictures here to that effect. Events are when something happens. So an event is something that captures a fact of the past, and then we can go and do something with it. And you have effectively two choices. Either you don't care, that's a choice. Ignoring an event is perfectly legitimate, or you jump into action. When you jump into action, when you decide in your application to do something, then you are usually executing what I call an event-driven flow. But you may also execute work in an imperative flow. Those look very similar, but the motivations are different. An event-driven flow is something where the acting application volunteers to do work. Meaning, the party that has raised the event has no intent of making someone else do something about that fact that just happened. But there's an application, there's some code that volunteers to do work related to that event. It observes, then decides that it wants to do something, then it acts, and maybe it will tell others about it. Which means it then kind of, again, volunteers that information, that state change to others. The imperative flow, you're told to listen to something, and then you obey a command that comes down the pipe, you execute it, and then you respond. Those activities and the things that you do technically are the same things, often running through the same infrastructures. They just have different semantics. But keeping those separate matters. And it matters because the first one, event-driven flows, are how you drive extensibility in applications. And the second is still a form of coupling where you have a dependency between parts of a system, even though they look alike. And that is super difficult. And I have the luxury of being able to think about this problem of messaging and what messages are, which is seemingly simple, right? It's not for every day. And it's like it's slowly kind of revealing itself, these things, like where are these actual differences, and it takes a while. So imperative is you usually have some coordinator and a predetermined flow. And we've had already examples today in those talks where you have a workflow, you have some predetermined set of steps that are being executed and are being routed to actors. And you will have that in very many scenarios, and there's nothing bad and nothing good, and it's just fulfilling certain steps. A predetermined business workflow, that's not event-driven. That's an imperative flow, and that's okay. So you have an orchestrator, you have a coordinator, you have a choreographer. All of those are patterns, but they're ultimately all doing the same thing. They're telling actors predetermined steps to go and execute. And this may be happening synchronously, this may be happening asynchronously, all fine. An event-driven flow is when the boss here, in this case, right, there's the boss, wears a tie, so therefore can be seen as the boss. Doesn't give a command, but expresses effectively an idea. It would be nice if we could. And then some enterprising scientist says, well, good idea. Maybe you could do a following thing, and then just voices that. And then some enterprising engineer says, hey, great idea. That looks like a great plan. Let's go and do this. It's a bit idealistic view of the world, obviously. But it's more driven by giving information, handing information out to others, and then having those others go and make a self-determined decision of what to do with it. Very different. In the first picture, the boss needs to know everything, and the boss needs to be able to predict the future completely, and needs to understand all the steps. In a model where you deal with events, you give an impulse, and then you allow for extensibility to kind of drive that system further. So it's a very different way of thinking about the same thing, even though the mechanisms and how that all works may be very similar. So imperative, you have an execution plan, and you have predetermined roles. Work is assigned, executed, completion is reported. And when you make changes to that plan, you have to go and change the internals of that entire process. It's hard to go and attach and add anything to it because it's a program. With event-driven flows, there's no predetermined execution plan because you didn't raise the event with the expectation that someone does something. Work is volunteered, reacting to things, and changes, extensions, all those extensions are local concerns where you get an event from the outside, you go and do some work, but you can go and take that piece of work, you can take that process, and whether that exists or not doesn't make any difference to the rest of the system, but you can tactically add some functionality that runs for a week, and then you turn it off, and nobody's harmed because you're just reacting to events. So it's a different mindset, different approach, and you will always have both because there are imperative flows where you really need to have like the bossy this, but then it's always important to allow for extensibility, to yield event information, yield state changes, so that someone can go and then volunteer to do some work in the context. They can go and extend things. So having both is important. I'm going to tell you a short story about football. For the Americans, football. Sorry, had to be. I work for Microsoft, but I'm also on the Digital Advisory Council called the Digital Circle of German Bundesliga side Borussia Mönchengladbach, who have also played Champions League 2 years ago, and then we really sucked this year, and we sacked the coach and did all the right things, but we're on the right path. We'll be dominating the world real soon now. Anyways, so before the pandemic struck, that's where we had some really good things going, Champions League, etc. Had huge ticket sales, and we had a ticketing system which was really terrible, horrifying. Like we had a big sale, and then people were literally getting in line behind a proxy that was kind of set before that sales system, and people were sitting in line on a live socket on an HTTP server for like 3 hours. So people would just sit there and just stare at their computers and see a number counting down when they would be in line. So they were literally physically in line in front of a digital system, which was not source for great satisfaction. So we had to say, okay, we have to go and do something, and there was a decision of whether we want to go and build a new system ourselves. And me as an advisor, I said, you're in the football business, you're not in the IT business, you should not be building this. So we picked a partner, and that partner is Eventim, and Eventim has a ticket portal. And that ticket portal does everything that we need. And that was fantastic that we made that decision from a business perspective, because with the pandemic, and sometimes you can only sell 1,000 seats, and sometimes you can only sell 10,000 seats, and sometimes you have to go and do a lottery and do 300 seats. All of that nonsense would have been completely impossible to do with a custom solution. So that was the right call at the right time. We did the integration with the backend ERP system with 2 developers who have before only done Dynamics in the built-in CL language programming. Very little experience with C#. But we did that integration between the ticketing portal for the flow of the tickets and all the accounting data and all that with those 2 guys in basically 4 weeks. Plus a bit of learning, like 6 weeks, 8 weeks of kind of getting them to the point where they could do functions with C#, but not a big deal. And we could do that because the folks at Eventim have an API which is the reverse of what you would think of as a normal API. What they have is they have an open API one-way interface that they give you and say, go and implement that. And then, once you've implemented that, they call you. So they have a webhook interface, but that webhook interface is what they give you. So they raise events into your application. So we took that open API, code-gen that into Azure Functions, and then simply implemented that in Azure Functions. What did we do? So this is this ticket sales flow and the accounting flow. We then go and took from the Azure Functions, put the data into Service Bus Queue, and then in the ERP system, which still runs on premises, we built a little queue listener inside of Dynamics, pulled the messages out, and then go and did the insert operation in Dynamics, because that's what they knew. So for them, the net new work was learning how to do the Azure Functions implementation and learning how to go and take that message that was given to them and wrap it and put it into a Service Bus queue. That was new for them. But that took them almost no time. So that was not a huge integration job. Now, the eventing system is completely untouched by this, right? They simply go and just call events when something changes in their system. They also offer an API, which is another event interface, how we can go and tell them state changes in our system. So when there's a new customer record created, we basically say, hey, we have a new customer record created, and they then go and put that into the database. So it's a bidirectional, event-driven interface, and made it super, super easy to go and do that kind of integration. When a ticket is being sold, That ticket then also, that same ticket activated event or whatever that's called, I forgot the detail, then also goes to Access. And Access is the company that runs the server that's in the stadium that clears the tickets. So you come with a ticket, you hold that under the ticket reader, that goes to a database, it makes a lookup whether that ticket is okay, and then lets you through the gate. That integration is done through also the same event-driven flow. And then from the ERP system, when a new customer is being created, and it might be a new customer that has been created in the ticketing system, flows to us, and then we raise the fact that we have created a new customer. We're also pushing that into the single sign-on system, which is how you kind of log in. So all of that is completely event-driven and has been made possible because Eventim has been so visionary, really, to build that sort of interface. And that's something that I found, like I started this work with them and said, wow, you've done exactly the things exactly as I would recommend that you do them. So that was a very good collaboration. What you can do with events, right? They have not built the system for attaching a Dynamics CRM ERP system to it, certainly not in the form that we have it, but they're making those events available that makes it super easy to go and do that integration. Super story. But eventing is not always those discrete events, but you also have event streams, right? So you have here Colibur games. I picked a case which is which you can read on the customer reference site. We don't have as many as I would like in terms of these reference cases. But here you have effectively clickstream information that's coming from the games. As the games are being played, they collect telemetry that's running through event hubs, then gets analyzed using Stream Analytics, and then stored for further analytics in the data lake. Retail recommendations. Again, here, clickstream out of a website, and there's two paths. One is the data goes hot without going through event hubs even into a service fabric cluster where the data is being analyzed within milliseconds in memory, and then for further evaluation that goes through event hubs. There's a difference between event grid and event hubs that has to do with how things hang together. Right? Discrete events are all independent. Event streams hang together. I'm going to go get back to that in a moment. So, the way how I've started to talk about these elements of event-driven architecture at the bottom is as follows. There's a signal, and the signal captures an occurrence. The signal is the data that you would convey with an event. It's effectively the temperature reading. It's the fact that the customer record changed and maybe what the delta is. That is the signal. That's the information you want to go and convey. That signal is now being wrapped into an event. The event really is the envelope that's wrapped around that signal and makes the signal understandable by infrastructure that routes it. So the signal is what your application cares about. The event is what the infrastructure cares about as it routes it. And of course, the infrastructure also includes the dispatch logic in your own applications. Right? But once the signal has reached your handler code, you only care about the signal. The signal will be the parameter or the parameter list that goes into the handler function at the very end as you go and handle things, not the event per se. An event stream forms when you have multiple events coming from the same context and when they're important in that order from that context. So, for instance, that's the example I always use. You have a temperature sensor in this room. The temperature sensor reading at any given moment is meaningless because air fluctuates, there's humans here, you're all kind of your own space heaters, 37 degrees, etc. And so this air here that goes by a sensor has a different temperature any moment. So any individual reading is worthless. But what you need is you need to have a view of that temperature over time, and you can tell whether the temperature goes up or down, kind of by average, over the course of like 5 minutes. And if it gets hot in here, like per trend, then you may want to go and turn the air conditioning up, but only by trend. To do that analysis, all these readings need to go to the same place, which means you need to go and keep them together as what I call a stream. So an event stream in that nomenclature is not a Kafka or an event hub. Right? That's the big infrastructure that funnels it. But the event stream really is a set of events that are related to one context. And then you can have multiple of these event streams, a bundle of event streams, assigned to a partition. That's kind of the nomenclature that I like. So event stream is really a logical bundle, a logical stretch of events that are related to each other. Jobs, imperative flows, are not events. Events are completely told stories of the past. I made this temperature reading. A job is an expectation for the future. They look exactly the same as a message, right? If you have an AMQP message and it's an event or it's a job, you have to go and look at the semantics. The technical detail is the same. So what can be signaled, sorry for that slide, advertisement clicked, smoke detected, engine oil pressure read, delivery address changed, pizza ordered, aircraft rotated, it took off. That's just geekery. Aircraft landed, payment collected, calendar entry created, change committed, database record inserted, file created, venue seat ticket purchased, object velocity differential calculated, visual object classified. There are these state changes or observations that are in every single system that you guys write. And certainly in every application, in every business application. It will be great, and for integration, it will be gold, if a business application simply makes a statement as an event about every state change that happens in the system. CDC, change data capture, which is the way how you can go and attach kind of a reader to a database and then have kind of the changes of database records being reported out as events. That is kind of the hack that is being attached from the bottom to applications where you say, all right, so you don't want to tell me what's going on? Well, I'm going to go ask your database what's going on. But ideally, every application, with every state change, is ready to go and raise an event, because every event is an opportunity for extensibility. And even if you can't think of a reason today, someone might tomorrow. So even just sitting there, hand-wringing about, oh, am I going to go and report out the change of this object? Yes, do, because you don't know what people are going to do. Events, then, put those signals into context. And context means that in a complex system, like here in this IoT scenario, which I'm going to paint, every individual sensor in a house, right, gives out data, and the data is relatively trivial. It's a sensor reading of some sort. There's gas and biohazard, climate, fire and smoke, occupancy sensors. And the occupancy sensors basically just counts the people who are going in and out of a room, or who sit in that room. It's not complex data. But that data is not useful unless you give it a frame of reference in saying, where does this come from, and what is this about? So you have to go and say, this is in this room, is in this unit, is in this floor, is in this building, is on this site, is in this org. Now every single one of those signals now has a reference point, has further metadata that's associated with it that allows you to put that into a stream, get it out of a stream, and kind of be reason about what that particular little sensor does. The sensor itself just has a signal. It says, I just read this temperature. So we have to go and build in a system, we have to build a reference frame around it. And those reference frames then express themselves in paths, in hierarchies. And those hierarchies are then can be represented in the event. And that is why, for instance, in cloud events, but also if you look at MQTT and how that's being done there, you often have a notion of a path through a graph that kind of classifies what that message is about because it gives it context. That is, in cloud events, the source. Source is that sensor where that comes from. Once you have classified all your event sources, once you've organized them, you can do interesting things. You can go and start answering questions. I'll get that on the next slide. There's a relationship between signal observation, signals, jobs, and that is a signal, a standalone signal, may be immediately actionable. So a fire alarm signal is immediately actionable. You better action this now. Like if the smoke sensor says it burns, you want to go and take some action. The same is true for the customer shipping address just changed, right? That is, that nothing comes before that, nothing comes after that. You either take action or you don't. So that's immediately actionable. It might be that the fire alarm then gets routed further on, as it is with all the details, and turns into a job. So it's captured as an event, but then you might go and decide to go and act on it, and acting on it might mean that you go and take that exact same signal data and send it to someone else to go and cause something, but as a command. That's okay. Again, it's all semantics. But it's all about thinking about a path and the roles of the consumer and the producer, etc. And then you have these observations, as I just said. The individual temperature reading is not important, but the average is. Once you reach a threshold on that graph, then you reach a point where you want to now report out as another signal that you've crossed the threshold, because that's the point where you want to go and do something about it. So you can think of this, if I may remind you of math. I know that's hard. we did these curves, and then kind of finding the zero, the Nullstelle. What's that in English?
What is that?
Yeah, in calculus, anyways. See how good my math is. Anyways, so what you want to find is you want to find the extreme points on a curve, or you want to have signal points on a curve. And once you do this, you have a kind of a derivative. The derivative function does that. So you can think of these signals that are being raised out of these aggregate. We have an aggregate, and then the aggregate crosses a certain boundary. You can think of those as derivatives, as you do in math. So signals and signal streams cause further signals when you have done some analysis on them. And those are actionable, while the original signal is not. And so once you've structured your stream, once you've structured your signals within a context, you can now start answering questions. You can start answering questions like here. Are there people in room 41 3J4? Well, you have an occupancy sensor that is from that particular room, and you've observed what it has reported, and you have an aggregate of information, so you can go now answer that question. So these event streams yield effectively a state that sometimes is aggregated in the message broker even. So there's like MQTT has a feature of retained messages, for instance, where you can have that. Or that is being aggregated by something like Stream Analytics. But you can answer questions now related to the events that were happening because you have a structure in your system. Because you put those signals into context. There's a bunch of infrastructure that exists for streaming, for discrete events, for commands, and also for aggregation. And I have not only ours here, but also the ones of the competitors, mostly just to show that this is not something that's an accident, but everybody has them. And of course, the AWS people sometimes build a thing because we built a thing, and then we build a thing because the AWS people built a thing. That's all right. But there's apparently patterns here that customers are using that makes sense to have separated infrastructure, because those separated infrastructures do different things. So for concrete events, there's these discrete event routers. Event Grid, Event Bridge, Knative eventing have all the same characteristics. And those are that you're pushing events, you're sending events into an infrastructure, and then you can go and push that out to other parties, including those who handle webhooks, and you can reach over HTTP, because ordering doesn't matter. So you can use effectively the existing mechanisms of load balancing through HTTP load balancers. You can use all those mechanisms. You can use serverless infrastructures without any further complication to go and do event handling. Because these discrete events don't need to have any pull complication. With an event stream engine, Event Hubs, Kinesis, Kafka, Pulsar, Pravega, many others, you have a different thing, because you need to go and pull the event towards you, because you need to aggregate state. And if you want to have an aggregator, right, like Stream Analytics, you need to go and pull towards that state, because it's an event stream. Context. It's important to keep those messages together, which means you need to go and pull out of the event stream aggregator. That's a different architecture. So event stream engines and these event push discrete event brokers are different pieces of infrastructure, because they're solving a different pattern problem. One is pull and one is push. And then there's these queue PubSub brokers, Service Bus, SQS, SNS, Google PubSub, ActiveMQ, RabbitMQ, IBMMQ, all those provide queues. What makes those different? A queue provides, first and foremost, exclusive ownership of a single message for the duration of the processing. That is what that does. And none of the other brokers do that, because they're all for PubSub scenarios. Everybody can get an event, past facts, and not future expectation, a job. But a job can only have one owner, and the queue deals with assigning that to only one party, and then making sure that that event, that message goes through a lifecycle management that makes sure that that exclusive owner can go and decide what the fate of that message becomes. That's why that's different infrastructure. What's super important, and I'm sure you're all seeing that all the time, is that event streaming is not the modern way of doing queuing, because that's just nonsense. Customers are coming to us pretty much every day saying, well, we're going to build a modern queuing architecture with Kafka. And we're like, no. It's an event stream broker. It doesn't have queuing characteristics. Don't try that. And people are doing all kinds of weird stuff, including like the calculating the lag on Kafka, because there is no count for how many messages you've consumed, because it's not a queue. So it has nothing to do with modern or more traditional. It also has nothing to do with more scalable or less scalable, because ultimately a Kafka partition or an event hub partition doesn't scale higher than a service bus queue does, right? And we're adding now more partitioning. We already have partitioning in Service Bus Standard. We're going to add more partitioning in Service Bus Premium to have similar characteristics, but with the ability to go and have exclusive ownership of a particular message, because that's the feature what a queue has. It's a pattern. It's not more modern or less modern. You need to have that if you want to go and execute jobs. And all the other infrastructures are just not good at it. So most modern apps use both eventing and queue-based messaging and RPC. The core functions, kind of that's the vertical here, the core functions of an application are more tightly coupled. You have more intent of what the flows are. You are calling operations. You may be calling those operations, passing a queue. You might be doing that using RPC. But these are all predetermined things that are in the core of the application. Those are typically more tightly coupled, and they typically use RPC or queuing. And then you report all of your changes, and that's where the extensibility piece starts, and that's the horizontal part. And that's where you use event grid, event hubs, where you tell other parties about the stuff that you did and that happened inside of your system, and allow them to tap into that and extend it. So both of those things are important in pretty much every modern application. Why are event streams the way that they are? Why is event hubs, why doesn't that do individual message tracking? Why doesn't that have server-side filtering? And even though there is this pretty significant competition between between event hubs and Kafka and some other brokers, why don't they just go and add the features? Because there's an architectural reason for them having fewer features, because they're built for speed. Event data has value, higher value if it's fresher. The extreme example is at the securities markets. Market data is worth nothing if it's 15 minutes old, but is super valuable if it's 2 seconds old. The money is being made within that 2-second, 3-second window, and sometimes even shorter. And NASDAQ, that's the bar in the back of it, NASDAQ is actually merging reference data into the market data if you get tier 2 data, because they are sitting right by the source. And they can give you reference data into the real-time data quicker than anybody else could. So they're selling that as a higher tier. They're giving you more data. Some of that data is actually from reference sources, but that's okay, because they can go and deliver that to you with that real-time data in time faster than anybody else could. Freshness is the feature here. At the end, when you archive that data, then it gains some value again, but really the sweet spot is the first few seconds. And that's true for many of these real-time scenarios. Real-time meaning fast. And so you build infrastructure which is optimized for speed. Now with Event Hubs Premium, we can do end-to-end, give me the data, replicate it 3 times across availability zones, and then give you the data with a latency of 10 milliseconds. If you're lucky, 7 milliseconds. That is, those 3 replicas across 3 availability zones have been written flush to disk during that time. It's super fast with very minimal jitter, and you'll hear Kasun talking about this, and so you'll learn about it. Yes. Well, you'll hear someone talking about this. I think Kevin might talk about this. Yes, okay, good. So Kevin will tell you all about it. So you'll learn about the performance characteristics. So there, you need to have parallelization. That's why you have these consumer groups. That's why you have these extra features, because you need to go and take this super fresh data and process it in parallel. That's why those event stream brokers have those features. They don't have filtering. They don't have all the circus kind of built into the engine, because its speed is the thing that matters. That is the feature that they have. Organize, catch rain, as I call it. Catch the rain in all those events, organize them on disk, and then make them available for consumption as quickly as possible. That's their job. Now, important to note that on the other side of the time axis, there's a desire that people express of like, oh, I want to do event sourcing, and I want to save my raw events from the beginning of time, and then when I want to have a new projection for my data in a different database, I want to read the events from the beginning of time. Okay. So if the beginning of time is 4 weeks ago, I will believe that. If the beginning of time is 5 years ago and you have a non-trivial system which is scaled to the transactions that you run, there is no chance that you will ever catch up. event sourcing from the beginning of time is nonsense. But it's great for distributing information that comes in live to multiple sources, and then sometimes you may want to go and build a projection of a database that has been built from events and then keep it up to date using events. That's great in event sourcing, but this whole notion of it being a forever database makes very little sense. Unless it's a specific time series database that has extra indexing. Now, there is because speed matters, because of the primary axis that you process events through one of those event stream systems, because the primary index is time, that is how the real-time aggregation, that can be that fast because it only gets the data kind of around the time axis and then processes it around the time axis and can go and segregate them by context. First index, primary index is time. Second index is the partitioning key. And that's all you deal with in these real-time analytics scenarios. As soon as you have further criteria, this all gets complicated. So if you're looking back at an event stream for an analytics purpose where you want to go and look back in time, and you need to have other criteria, like, oh, this car had a problem last week, and I'm suspecting there was something wrong with the oil pressure, so let's look at the telemetry, and now I have two search criteria that are not in that stream. I can now choose to go and dig into that stream like without any indexing, or, and these are facts, which means they will never change again, I can go and just spool the event stream as it comes into a database where it gets indexed, and then I go and ask those questions out of the database. And that's exactly the attitude that we have in Azure Data, in integration of those services. What you will do is you will go and take the event stream, you will analyze it in real time using real-time tools, but you will also spool into the database, for instance, ADX, for instance, Cosmos, for instance, SQL, and that's where you will ask your historical questions. So the way how we look at this platform overall is a platform which does real time, but which also has a database element to it, where really, if you want to ask the harder questions, where you want to go and really use indexes, don't keep stuff in the event hub. And really, the retention periods that we have, 7 days, 90 days if you stretch it, they're causing the discussion. It's harmful to keep the data forever or just retained by size, because what are you going to go and do with that data reasonably? You have to force in your architecture a split between freshness and things that you want to retain for a longer time, but when you retain them for a longer time, you have to have them indexed. All those events go through journeys, which means they originate somewhere and then they run through a system in multiple stages. And I'll be 5 minutes late. Because that is so, we created CNCF Cloud Events. CNCF Cloud Events is a standard project that we've co-started in the Cloud Native Foundation. And what it does, it defines what an event is and maps that event to various different protocols. It doesn't implement or invent its own protocol, but it maps to existing ones. And the goal is to have an event being raised from, for instance, a device, but it really can be anything, and routed through multiple layers of a system, and popping out on the other side, still retaining the same semantics and the same information. And with allowing the optimal use of the protocols, meaning you don't go and just always wrap it into JSON and then transport it, but you need to be able to go and take the semantics, the information that is really designed for the infrastructure, it's an envelope, right, the event, and expose that to the infrastructure so it can go and work with it. So that was the goal for the Cloud Events project, and that's catching on. It's doing pretty well. I said, we're defining what an event is, and then how to map that to certain encodings, and then to certain transports. It's a very legible spec, I believe, so you should go and take a look at it if you don't know this yet. It's in GitHub Cloud Events spec. And then we're doing some current work, and that kind of ties into what Balan said about a catalog of APIs. So there's a catalog of APIs. So we have open API, an effort that we engage in, etc. We have touch points we're talking to the Open Async API project, and we've been kind of so on the work, but there's a podcast, there's a podcast that we just did last week, which is interesting to learn because we're kind of coming closer, I think. And in cloud events, we're also doing work around metadata, and I think that all will go and come together, and our goal is to, as Balan said, have a catalog of sorts. And so what do we need that catalog for? Because eventing data, here the signal is not only used inside of messages. You have a message where you have the signal, but that signal also goes into a storage file. It will be used in a business app. So have that structure, if that's encoded, let's say, in Avro or in Protobuf, we need to go and have a common place where we can go and share that schema. And there's a schema registry. So the schema registry is the most foundational piece, and that's used by most software pieces, whether they do messaging or not. If you have schematized data, which is not being sent including the schema, but just using a schema reference, you have to go and store that somewhere. And you need to be able to go and replicate that information to other places. So that's one piece of work that we're doing. Then you also want to have metadata that's describing that data when it is on the wire, when it is in part of an event. And these are message definitions and message definitions groups, and those go into a message catalog. That's the second piece of this. And then, of course, you have these message catalog, these messaging groups related to a service. You then will want to find where are the endpoints in my system that understand these messages or that yield those messages. Right? When I talk to an endpoint, can I enumerate what messages may come out of that? Can I go and stare at a queue and ask the queue, which messages are legal on you? That'd be great, because now I can go and generate code, both for sending and for receiving. And that's what we call discovery, the subscriber endpoints and producer endpoints and consumer endpoints. And we have mostly in the working group kind of figured out all the pieces, and now we're just talking about details of how we're going to go and put those together. But that's the foundation for then also future part of the work that we're doing. That's work that's happening in cloud events. So overall, you have already heard the story told by Balan and others. On the far side, there is logic apps being an integration bridge to many, many systems. And then when we talk of triggers, that's really a translation of something that happens in the business system or a native event that's coming out of the business system that then starts a workflow. Sometimes that workflow is as simple as to basically just hand the message over to another system, or it's a more complicated integration. And at the core of that, and that's of course the perspective that we have from the core messaging team, all those things run through the core messaging services. And then we have associated services that go with that, Web Hub Sub, SignalR, IoT Hub, communication services, notification hubs, which can then also be fed from those systems. And of course, the entire world of Azure Application Services and Azure Data integrates with the rest of that platform. So we have a lot. We have strategy, integration, standardization integration that we do with others. We have lots of services that we're building, and we have tons of infrastructure for building event-driven applications, and we're making further investments. And I hope that was somewhat useful, that I told you all those things today. And with that, I think you have a lunch break. Thank you.
Cove.co